So in this video we can have to discuss about the actually types of circuits and also how can be able to have the total resistance in a actually series circuit as well as the parallel circuit. So what is a series circuit and what is a parallel circuit? Now let's say we have a circuit with the components should be the resistors. Now should be and say this is a battery in that way, and we have another resistor that which is going over like that. So now let's say this is a resistor 1, this is resistor 2, and let's say this is resistor 3. So now this is what you call the series circuit, where the components are being connected in a single actually wire. And you should have to understand that this is a battery that is the source of the potential difference or source of the actual driving force. That is the battery. And we have the flow of the current, and which is, let's say, going over like that. So which means this is the current I, and that is upon, let's say I should have to present the switch somewhere. Let's say there is a switch somewhere. Let's say this is a switch. So if we close the switch, the current will happen to flow actually along the circuit for each and every component. So now the current will be given as the I. So what are the facts behind the series circuit? So a series circuit has actually all components are connected in a single wire. So all components are connected. So should be all components are connected in a single wire. So take note of that. All components are connected in a single wire. Now that is about the series circuit. And I should also have to understand that there is no junction. So in a circuit, actually in a series circuit, there is no junction. So there is no junction. So now, much as all components are connected in a single wire, no junction will be present, because if we say the junction, that's where more than a single wire are actually, that's where more than actually two wires are actually intersecting. For instance, let's say we have this as the wire. So this is a corner, not a junction. And it's true more this is a single wire, because we can have it in this way, but since we have thought of twisting it, this is the same as the wire. But if we have this case, let's say we have this case, now this is a junction, because we have this wire, this wire, this wire being meeting this point. So that is the junction. So in a series circuit, we do not have such kind of a junction, because we do not have the more than two wires being actually emitting or being connected together. So that's the principle behind the series circuit. And I also should have to understand that the current at each and every point remains the same. So current does not change. So current remains the same. So that is, the current remains the same. The current does not change. So the current from the battery at each and every point within the circuit does not change. It remains the same. At this point is having the same current, and also at this point the same current. At this point is also having the same current. At each and every point within the circuit, the current remains the same. So take note of that. And finally, you have to understand that the voltage is what is being shared actually across the circuit. So which means at this point to have its own voltage, and at this point to also have its own voltage, and also at this point to have its own voltage. So in other words, the series circuit only voltage is what is being shared, but the current remains the same. So that is, so we can have different orientations actually about, we can have different circuits that are possessing the series circuit. For instance, let's also have to appreciate this kind of a circuit. We can have also this kind of a circuit, but Strumo, this is the series circuit. You should have to understand. Let's say have, in this case, no matter how twisted the circuit can be, but much as the components are connected in a single wire, then that one is best to be said to be a series circuit. And for the case, this is also part of the series circuit. No matter how wrong the components, or no matter how actually the circuit has been twisted, but much as the components are connected in the single actual wire, then that one is a series circuit. So now, let's venture into the parallel circuit. What is the parallel circuit? Now the parallel circuit is the opposite of the series circuit. Let's say we have a circuit. Let's say this is a typical circuit. So now this circuit, let's say this is resistor 1, this is resistor 2, and this is the resistor 3. And this is the battery in that case. So all these actually resistors are in actually parallel circuit. This is the parallel circuit. In much as we have the presence of the junctions. So this is the junction, this is a junction in that way. This is also junction, this is also the junction. And the components are connected in more than single wire. So we have this wire and this wire like that. So this is a typical, actually a parallel circuit. So what are the facts behind the parallel circuit? So in this case, you have to understand that in a parallel circuit, the components are connected in more than single wire. That is just that the opposite with actually series circuit. So you should also have to understand that we have the presence of junction. So junctions are there as well. And the current is shared. So in a parallel circuit, the current is shared. Unlike with, so the current is shared. Actually, unlike with the series circuit where the current remains the same. So current is shared. So should be this. What's the spelling of the shared? So should be this. So the current is shared. And I also have to understand that actually the voltage remains the same. So voltage does not change. So the voltage does not change. So that is, these are the principles behind the parallel circuit. So which means the voltage from the battery at each and every component remains the same. So which means at this point the voltage is the same, at this point the voltage is the same, and also at this point the voltage is the same. What is only being shared is the current. For instance, let's say this is the current from the battery. It is going towards this direction. At this point the voltage, okay, the current will be shared. some will flow this direction, and someone also and some also have to flow at this direction. So the current has been shared, so which means the current that will have to flow at this point won't be the same at this point because the current has been shared. So that's how you have to understand about the parallel circuit with respect to the current flow. So the current is shared, but the voltage does not change. So take note of that. So how can you be able to have the total resistance in a parallel circuit as well as the series circuit? And for instance, let's say we have a series circuit, and of course we can also have the combination of the parallel circuit as well as the series circuit, but we're going to look at those things and within the same video, as we'll be able to analyze some cases to deal with the resistors. But check it cool. Let's say we have actually a series circuit with resistors. Let's say it going over like that. And now say this is resistor, this is resistor 2, and let's say this is resistor 3, and say this is the source of voltage, and that should be that. And we have the flow of the current which is going over like this. Let's say this is a current, that is the symbol for current. So now you have to understand that the current across R1 is the same as the current across R2, which is the same as the current across R3, much as this is the series circuit which is given as I. So take note of that. We say that actually the current in a series circuit does not change, it remains the same at each and every component. So this is the principle behind. So now only voltage is what is being shared, in the sense that the voltage across R1 resistor, according to the Ohm's law, we can have it as R1 times the current, that is, so R1 times current, so should be R1 times the current across actually resistor 1, which is given as current R1, and the voltage across resistor 2 will have it as R2 times the current across R2, and the voltage across R3 resistor 3 will have it as resistor 3 times the current across resistor 3, of which the current remains the same. So in this case we'll have it as the voltage across R1 resistor will be having it as R1 times the current, and the voltage across R2 resistor will have it as a current, that should be R2 resistor, so should be resistor 2 times the current. And on the same note, we can also have it as the voltage across resistor 3 will be given as the resistor 3 times the current. So that is the principle behind that. You should have to understand that and about. So you have to get it that what is the actually a voltage, which is what is the total voltage of the circuit. So now you have to know that the total voltage of the circuit is that of from the active battery. So now since it is being shared, you see that the voltage across this one will be subtracted from this one, and across this one is subtracted from this one, across this one will be subtracted from this one. So now for instance, let's say the battery is having, let's say 6 volts. This is 6 volts battery. Let's say that's the case. So in this case, let's say R1 resistor is consuming about, let's say 2 volts. So which means, or half 4. Let's say this one is consuming about, let's say it's consuming about 3 volts. It means we are remaining with, let's say 1. So which means this one will have to consume 1 volt. So which means the voltage has been totally shared within the components in the circuit. So across this actual component, you see that we'll have the overall zero voltage in the circuit. So which means the voltage has been completely shared. So take note of that. So if that's the case, then it means the total voltage from the battery will be the sum of the actual shared voltages. So in that case, we'll have it as the voltage across R1 resistor plus the voltage across the R2 resistor and plus the voltage across the R3 resistor. This is true. And the voltage from the battery, which is the total, is equal to, what are these actual voltages? According to the Ohm's law, we'll have R1 times the current, and the R2 times the current, and R3 times the current. That's the principle behind. So since the currents are the same, we'll have to factor them out. So now we'll have the voltage is equal to now a current times R1 plus R2 plus R3. So it should be that. So now as it stands there, R1 plus R2 plus R3, what is the message that we can be able to depict from that information? So R1 plus R2 plus R3, it tries to tell us that that's the total actual resistance. So which means we'll have a voltage is equal to current times now R total, which is the total voltage, or can be given as the equivalent resistance. Actually should be R total, which is the total resistance. So which is the same as the equivalent resistance. So in this case, you can be able to see that the total resistance is given as the R1 plus R2 plus R3. So that's how we find the total resistors for the actual resistors that are connected in a series circuit. So we just have to literally add them algebraically. You just have to add the resistor for this one plus this one for actually plus this one. That is for the resistors that are in parallel, actually that are in series. So we literally add them. So that is the formula. And of course, what is the general formula? We should have to know. If this is the case, then this is true. So equivalent resistance, which is the total resistor, has to be given as R1 plus R2 plus R3 and plus Rn. This is for the circuit which is having actually a resistance, more resistors, where you just have to literally add them that way. And also you'll be able to know that the total resistor and for the resistors that are in series circuit, it is more than the highest resistor in the circuit. And for example, if we have a circuit, let's say R1 was given, let's say 5 ohm resistor, this is the 10 ohm resistor, let's say this is the 20 ohm resistor, you'll be able to see that the total resistor will be more than the highest, which is a 20 ohm resistor. Because whenever the resistors are connected in a series, actually their opposition to the flow of the current increases. So you'll be able to see that whenever the resistors are connected in a series circuit, their effect to the opposition to the flow of the current increases. So that's why the summation, or that's why the total voltage, actually the total resistors, the total resistor for the resistors that are connected actually in a series circuit is critically more. So take note of that. So what if we should have to now understand about a total, actually a resistor for the resistors that are connected in a parallel circuit. What is the principle behind? So now let's say we have this as the circuit. Let's say this is a circuit. Now this is the paddling. You should have to understand. So now this is resistor 1, this is resistor 2, and let's say this is resistor 3. And there should be this is the paddling. And we have the current flow from the paddling, and towards that direction. Let's say this is the current. So now you should have to know that the voltage across R1 resistor is the same as the voltage across R2 resistor, which is the same as the voltage across R3 resistor, since the voltage in a the voltage in a parallel circuit does not change, which is the same as the voltage from the battery. So what is only being shared is the current. So what is the current across R1 resistor according to the Ohm's law? So now I'll have it as VR1 divided by the resistor 1. And I'll have the current across R2 resistor. We'll have it as the voltage across R2 resistor divided by the R2. And what is the voltage? What is the current across R3 resistor? We'll have it as VR3 divided by R3. So that is the principle behind. So now if that's the case, then the current, which is the current across R1 resistor, now will be given as the voltage over R1. And how about the current across R2 resistor? I'll have it as the voltage over R2, so much as the voltage is the same. And I'll have the current across R3 resistor, I'll have it as V over R3. So that is, and from the fact that according to the Ohm's law, current is given as the voltage divided by the resistance. So have that understood. And also from the fact that the voltage does not change in a parallel circuit. So now, what is the total current if that's the case? So now, since the voltage, since the current is what is being shared in a parallel circuit, then it means the total current, which is from the battery, has been literally shared onto this point, this point, this point, and the summation of the current has to be in this way. So have the current across R1 plus the current across R2 plus the current across the R3 resistor. Now, which is the same as now V over R1 plus V over R2 plus V over R3. So that is, since the voltage is the same, then let's think of having it being factored. So now in this case we'll have it as, let me just have to read this one. So now have the total current is equal to the voltage from the battery, the 1 over R1 plus 1 over R2 plus 1 over R3. So now what is the information can be able to depict it from there? So now since the numerator is the same for all, then this is true. We'll have the current is equal to voltage in that times 1 over now the total resistance. So that's the information can be able to depict it from actually this expression. If that's the case, then you see that the R total is the total resistance, and for the actually for the parallel circuit. So which means we can be able to have the total resistance. It should be this. So which means the total resistance and for the parallel circuit that are connected in the parallel circuit will have it as 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So that is the formula. So that's how you have to understand about the equivalent resistance, therefore the resistors that are in parallel. So that is the formula. So which means if we have more than 3 resistors, it means we'll have it as 1 over R4 should be that until you have them all. So take note of that. Now you also see that the total resistance is basically lower than the lowest resistance for the resistors that are in that particular circuit. So which means the more we are connecting the resistors in parallel, the more we are reducing the actually total resistance. You also see that effect mathematically. And for instance, let's say this is the 2 ohm resistor, this is, let's say, 5 ohm, this is the 10 ohm resistor. So you see that the total resistor will be less than this. Even if you're going to have to, let's say, add in another resistor, let's say 1000 ohm resistor at this point, Strumo will be literally reducing the total resistor and below 2 ohm resistor, because as we are increasing the resistance in actually a parallel circuit, we are reducing their actual effect in opposition to the flow of the current. So take note of that. And also you have to understand that since in a parallel circuit there is a decrease in the resistance, so in the parallel circuit the power is increased from the fact that, let's say, the formula for the power states that, let's think of this first. We have the formula for power, which is given as V square over R. Let's say that's the case. Now as it stands here, the power as well as the resistance are inversely proportional, in the sense that if we're increasing the resistance, the power is decreasing. If the resistance is decreasing, the power is increasing. So now for the parallel circuit, basically resistance is always being decreased. In that case, the power in the parallel circuit, the overall power in the parallel circuit is critically high. It is critically larger compared to the power in the series circuit. So in the series circuit, basically the resistance decreases at the same time. Actually, the resistance increases at the same time. The power in a series circuit is decreased, since the power is rated with a resistance in inverse proportion, in the sense that as the resistance is increasing, the power decreases. The resistance decreases, the power increases. So in a parallel circuit, always the power increases, and while in the series circuit the power is decreased, because in a series circuit we increase the resistance or opposition to the flow of the current, where the power also have to decrease as well. And while in the parallel circuit, we actually retry decreases the total resistance and making the power to increase. So for this case, what is the total resistance and for the resistors in this circuit? So now this is a series circuit where we just have to retry to add the resistance. In this case, we'll have it as R being given us, we'll have it as 10 ohm resistor plus 5 ohm resistor, 10 ohm plus 4 plus 2, and of course the overall units has to be given in the ohms. So in this case, we'll have it as, now should be a 10 plus 10, which is given as 20, and we'll have it as 29, and we'll have it as 31. So which means we have it as a 31 ohms. That is the R total for that case. So which means if we happen to add another resistor in the same series circuit, we'll have to experience the increase in the actually overall resistor. So that is. Now what if we also have this case? Let's say we have this resistor, actually this circuit. Let's say this is 20 ohm resistor, this is 2 ohm resistor, let's say this is 3 ohm resistor. So what is the total resistance in this case? So by the way, this is the series circuit, because all these resistors are connected in a single wire. So which means we'll have it as a 3 plus 2 plus 20, and overall units has to be ohms. So have it as 25. Now have it as 25 ohm resistor, and of which if we happen to add a new resistor, let's say in the same series circuit, we'll experience the increase in the overall resistor, which is the R. But if we happen to add a new resistor in a parallel, this one will be decreased with respect to that one. Let's say if the new resistor that will be connected in a parallel, let's say will be, let's say, 2 ohm resistor, then it means the total resistance, will be below the 2 ohm resistor. Take note of that. Let's say we have this case. Let's say we have and let's say this is a 5 ohm resistor. Let's say this is 2 ohm resistor, 2 ohm resistor, 10 ohm resistor, and let's say this is a 6 ohm resistor. So now, what is the total resistance now for this case? So in this case, you have to understand that these two resistors, 10 as well as 6, they are in series because they are connected in the same wire, that which is this wire. So they're in series. and while this and this, they are in parallel. So first thing, we should have to have the total resistance for those that are in a series circuit. So I have to say rate the R total between 10 should be 410 ohm and 6 ohm. Let's say B should be X. Let's say that's the case. So since they are in a series circuit, so which means we'll have to say X is equal to 10 plus 6, which is equal to 16 ohm resistor. So that's the essence behind. So now, which means the circuit has been now decreased to be now in this case. So now the circuit will be in this case now. So now this is the circuit where this is X, which is equal to 16 ohm resistor. That is the essence behind. So now we have all those resistors being now in a parallel circuit. So which means we'll have 1 over R total being equal to 1 over 5 plus 1 over 2 plus 1 over 2 plus 1 over 16. So now we'll be able to have the R total using this formula, since now both of them are in a parallel circuit. So what would be that one? Let me just have to use the calculator there. So which means we'll have 1 over 5 and plus, there should be a plus 1, there should be plus 1 and plus 1 over 16. Now of which we can have it as a 1 point, so which means we'll have 1 over R total is equal to 1 point, should be 263. So that is the way to go. So now, what is the value of the R total? If that's the case, we should have to make R total as the subject. So have it as R total is equal to 1 over 1.263. So what is that on? And of which we can have it as R total being equal to 0.7921 ohm resistor, as you can see. So which means the more actually resistors are connected in a parallel, the more actually the total resistor is actually decreased. At the same time, the more actually a power is increased for a parallel circuit. So that is. And also, let's consider this kind of a circuit. Let's say we have this circuit. Let's say this is a typical circuit. And of course, I'll have another video explaining some of the, giving out some of the problems to deal with, the way you can have to solve some problems to do with the total resistance. You'll be able to appreciate that video. But this is just an insight of what you have to expect. So that is, so let's say this is 5 ohm resistor, this is 2 ohm, let's say this is 20 ohm, let's say this is, let's say, a 50 ohm resistor. We have it as 2 ohm, 11 ohm, let's say this is a 5 ohm resistor. So try to have the total resistance down for this case. I think I should have to help you in that way, but you'll be able to come across different problems to do with these cases, so you should be able to have to go over those things. Now let's say it should be this thing. So first thing, we should have to add up these three. They are in a parallel circuit. So rate the R total between a 5, 2 as well as the 20 being given as, let's say, x. So which means since the in parallel have it as 1 over x, that's equal to 1 over 5 plus 1 over 2 plus 1 over 20. What is that one? So which means we'll have 1 over 5 and that plus 1 over 2 and that plus 1 over 20. So which is equal to 0.75. So have 1 over x is equal to 0.75. And what would be the x? X would be given as 1 over 0.05, which is equal to 1.33. So 1.33 ohm resistor. So which means the circuit has been decreased or has been reduced now to this case. Now should be this. Now this is x, which is equal to 1.33 ohm resistor. Then we have those two now, they are in actually series. Now try to have their total, then series, then you'll be able to reduce the circuit. Now it will be in this way. Where we'll have the summation of x and that plus the other, actually a resistor we had it here. So try to proceed that now, then you'll be able to have them as now in a parallel circuit. So take note of that. Of course, next video will be also some sort of problems to do with the equivalent resistance or total resistance in a parallel as the series circuit. But this is an overview. Now you can be able to understand that now. So at your own time, try to go through this. What are the advantages and the disadvantages for a series circuit as the parallel circuit?